All right, let's talk through this problem. So, you were asked to essentially prove that this is always true. And to do that, and they're kind of guiding you step by step on how to do that. So the first thing they told you was to think about a being m to the x power, b being m to the y power. And then what we want to do is write a times b using those substitutions. So I know a times b is what I'm trying to rewrite. So a times b is just, well, a is m to the x times b, which is m to the y. Now, if I simplify that using my exponent properties, I know that this can be simplified to just be m to the x plus y power. So what I really know here is that a times b is the same thing as m to the x plus y power, and we'll use that a little bit later on. All right, so the next part of this then says now take each of these expressions and the one we wrote here, which is right here, and turn them into logarithms. And that's what you see here. This becomes log base m of a equals x, log base m of b equals y, and log base m of a times b equals x plus y. So we just used our definition of a logarithm. Now what I want you to do is pause the video here if you haven't already tried to do this on your own. Now try to actually do part C, because that's really where the proof comes together. Remember, what we're trying to prove is this statement here. So once you've been able to show that this is true, that you get this from doing the algebra that we're doing, then you're done. So go ahead and pause the video, try it, and come back. Okay, so you're going to put everything together. It says in the third equation, you wrote the third equation you wrote for part B, so that's this equation right here. Substitute x and y, so what we know x and y are, which we have here and here, and obtain a log equation of base m that involves only the variables a and b. So in other words, we know that this equation is true, so that's what I've written here. Okay, now I know x, another way to write that, is the log of log base m of a. So where I see x, I replace it with the log base m of a. And then I know y is really the log base m of b. So where I see y, I replace it with the log base m of b. And look at the resulting equation. This resulting equation is exactly what we were trying to prove in the proof above. Okay, now give it a shot on your own here. Pause the video for a few minutes, try part D, which is basically doing what we did in part A, or in the previous three parts, but now using the quotient property. So go ahead and try it and come back when you're done. All right, and then here's what you should have for the quotient property. Once again, I used the very same steps that we used in the previous example. I wrote a over b using m to the x and m to the y, which I can then simplify because we know that when we are dividing exponents with the same base, we just subtract those exponents. So a over b just becomes m to the x minus y power. Convert each of these to an exponent, or to a logarithmic expression, and that's here. And then substitute in what you know x and y are to get your formula. And then just kind of look through 6.1.12. It's already done for you. You don't need to actually work through it, but make sure you understand it. These proofs are just an extension. They're a nice little kind of, it's the type of stuff that we look at in honors versus regular. And it's nice for us to see that, because when you start to get into your higher levels of math, you are going to be doing a lot of proofs based on some of the properties that you figure out, or you might not be allowed to use that property until you've actually shown that it works through a proof. Okay. Good job. Let me know if you have any questions in the question document, and we'll see you on Classroom.